Right, so today we're looking at environmental factors in landscape development. So last time we said that you can describe the land by the hill slopes, streams, and the soil basically. And what we're going to look at are what are some things that affect that. So crustal change, climate, and bedrock, how those things affect those descriptions. All right, so first off, uplifting. All right, crustal change uplifting. So I'm going from something that's low in elevation with a small slope to something that's higher in elevation with a greater slope. So that can be caused by folding, faulting, volcanic activity, could all do that. So what effect it has on streams? Well, uplifting the gradient of streams increases, so the streams become steeper. When streams become steeper, it's going to cause them to travel faster, so the velocity of the streams increases. And if the stream's going faster, then it's going to make it so it can have more erosion take place as well. Also, typically when you get increase in gradient, the streams want to go more so in a straight line too. Now, as far as soil goes, uplifting typically doesn't produce a ton of soil. One particular exception to that, though, is one type of uplifting, the type you get with volcanoes. Right. So like right there, got a volcano. Some volcanoes have mostly magma or lava come out. Other ones have a lot of ash come out of it. And this right there, there is some volcanic ash from Mount St. Helens back in 1980. But this can cover the land and make soil. All right, so that's one thing that can add soil with uplifting. But by and large, most uplifting doesn't create a lot of soil. All right, next, leveling forces. So I'm going from areas that are higher in elevation with a steeper gradient. As time goes by, pieces break off, get deposited down there. Pieces break off, get deposited down there. And the land becomes lower in elevation and it becomes flatter. So what's happening? Well, the grade for streams, if it's coming flatter, it means the gradient decreases. All right. As the streams get flatter, they're going to slow down. So you're going to have less erosion taking place if the water's traveling slower. As the streams become flatter, you're going to see more meanders in them. So the streams are going to zigzag back and forth more the flatter it gets. Now in areas that have lots of leveling forces, what we find is a lot of the soil there are transported soils. So the material came from someplace else and then dumped in a new location. Climate. All right. Dry climates. All right. If you've ever seen like pictures like the Grand Canyon or places out in Arizona, what you'll notice is that a lot of the features out in those areas are very sharp features. Right? In areas that have dry climates, they have very angular hills to them. Whereas in humid climates, pretty much in the United States, anywhere east of the Mississippi is a humid climate. Most of the hills where it's humid are nice and well-rounded. All right, so angular hills dry, rounded hills humid. In dry climates, a lot of the streams that they have on maps aren't represented by solid blue lines. They're represented by dashed blue lines. And what that refers to is that it's an intermittent stream. And what that means is a stream only flows once in a while. It doesn't flow all the time or doesn't flow very often. So, you know, during the course of the year, there might only be water flowing in that stream, you know, maybe a week or two. Because like around here, if it doesn't rain for a while, there's still water in most streams around here because even though it's not getting any runoff, there's still groundwater going into the stream. But in really dry climates, the water table's so far down that once it stops raining and the runoff's gone, there's no place else for the stream channel to get water from, so it's dry. So on maps, they're usually represented by dashed blue lines. Areas that have lots of rain typically are going to have a higher drainage density. There's going to be more streams more miles of streams per square mile than it would be in a drier area, because there's more water at the surface and it's carving out more stream channels and so forth. As far as the soil goes, well, remember the soil is the product of weathering and biological activity. Weathering is the breaking down of rock material. So the more weathering you have, the more soil you're going to have. All right. Well, if you think back to the types of weathering, frost action, well, you need water for frost action to take place, because ice is what causes frost action. Root action, well, you need plants, and plants need water. So no water, no plants, no root action. Dissolving, well, you need water for that. Abrasion, now there is wind abrasion, and actually in really dry climates, most of the weathering is the result of wind abrasion, but water abrasion is much more effective than wind abrasion is. So if you don't have water, most of the types of weathering don't happen or take place at a much smaller scale. So in dry climates, because there's little weathering, you're going to have not very much soil. So your soil is going to be pretty thin. And because there's thin soil and not much rain, you don't have very many plants. Whereas in a humid climate, you have lots of weathering taking place, which will result in more of the breakdown of rock material. So I'm going to have a thicker soil, and if I have a lot of water and thicker soil, I'm going to have lots of plants. When the plants die, they become part of the soil, and also the plant's roots help make the soil even more. Okay? So dry climates, thin soil; wet climates, thick soil. Now, areas that were covered by glaciers. Glaciers, the effect it can have on the shapes of the hills. Glaciers carve out U-shaped valleys. So they'll affect the shape of the landscape. In upstate New York, a lot of the features, a lot of the hills and stuff that we have around here, a lot of that was partially done by glaciers. All right. Areas that were recently covered by glaciers frequently will have poor drainage. All right. And the reason for that is that glaciers carry all different size stuff. When a glacier comes in, it brings all the stuff with it. Then when a glacier melts back, it just dumps the stuff on top of the streams and stuff that were already there, the drainage patterns that were already there. You're just dumping a bunch of junk on top of it. So when it rains and stuff, the water can't flow through the old stream channels, and it kind of just, the water kind of gets trapped, and you end up with poor drainage and like muddy and swampy conditions and so forth. So as time goes by, the stream channels and stuff will reestablish themselves. But initially, when the glacier pulls back, a lot of times you have really poor drainage because there's just junk covered all over the old stream channels. In areas that were recently covered by glaciers, most of the soil is transported soil because, again, glaciers came through with all sorts of junk. When the glaciers melted, it just dumps the junk right there. That junk it brings with it, may have come from 500 miles away. The glaciers scoop it up in one place, carry it, and then when the glacier melts, it dumps it in a new location. And because glaciers are solid, they could pick up any size particles. They could pick up grains of sand, they could pick up giant boulders. And when it melts, it just dumps that stuff there. So glacier deposits, the soil is usually unsorted particles, all different size particles mixed together. And again, a lot of places in upstate New York, if you go to a farm field and look at the dirt, you'll see some pebbles with the smaller stuff, the clay and the sand and stuff. You'll find pebbles and you'll find cobbles and stuff in there too. The reason why there's all those mixed particles is because in upstate New York, a lot of the soil is stuff that was left here by glaciers. The bedrock's effect on these. Right? Well, With the bedrock, rock that's relatively hard or resistant to erosion and softer rock, that's less resistant to erosion, will cause a difference in the shape of the side of the hill. Right? Where the rock's really hard, that's where it goes straight up and down. Right? Where the rock's softer, you have more of a gentle slope. All right? Now, of all the various types of sediment, well, first off, the Earth's surface is mostly covered with sedimentary rock. And of the various types of sedimentary rock, there's a whole bunch of them. There's really three that are most common: sandstone, limestone, and shale. Sandstone and limestone are relatively hard, shale is relatively soft. So typically, the sandstone and the limestone typically make pretty steep cliffs, where shale makes more gentle slopes. Right? Now, just by looking at the side of the hill, the shape of the side of the hill, I could figure out how many rock layers there are, and I can make some inferences about what those rock layers might be. So for example, let's say the side of the hill looked like this. All right. Let's say the side of the hill looked like that. Now from that, I can figure out how many rock layers there are. And how I'm able to do that is wherever there's a difference in hardness in the rock layer, it's going to cause a difference in the slope or gradient. So right there is probably a change in rock layer. Right there is probably a change in rock layer. Right there is probably a change in rock layer. Right there is probably a change in rock layer. Right there is probably a change in rock layer as well. So you notice wherever there's a change in slope, that's probably going to be a change in the rock type. Now, where it's straight up and down, that's going to be a rock layer that's relatively hard. That's going to be a rock layer that's relatively hard. That's going to be a rock layer that's relatively hard. And then where you have more of the gentle slope, that's going to be a rock layer that's soft. So that's soft. That's soft. And shale is the most common soft rock type. So this would probably be shale. That's probably shale. That's probably shale. Then this one, this one, this one are probably sandstone or limestone. I was able to do all that just by looking at the shape, the side of the shape of the hill right there. So it's kind of cool. All right, now what happens? So when you have a change in rock type, that's where you have these differences in the side of the shape of the hill. What happens if it's all one type of rock? Well, if it's all one type of rock, then you just kind of get rounded hills. You kind of get rounded hills because there's not going to be differences in the hardness to cause these like changes right there. So if it's all uniform bedrock, you're going to get rounder hills. All right, bedrock's effect on streams. Well, it's bedrock is what causes waterfalls. All right, wherever you have a waterfall, what you're going to have is a harder rock layer sitting above a softer rock layer. So if you have an area where the stream's got a pretty good gradient, where it's going to be changing elevation, and you have a harder layer sitting over a softer layer, what's going to happen is the softer layer is going to, since it's less resistant to erosion, is going to get eaten away more, and then it's going to be left with an overhang, and that overhang is what's going to cause the waterfall. Okay? So wherever I have a waterfall, I have a harder layer sitting over a younger layer. So like some of the more famous waterfalls, like Niagara Falls, you know, probably one of, if not the most famous waterfalls in the world. There's a layer of rock on top here. It's actually a dolomite, which is related to limestone, but it's a really hard rock. But then you get the softer stuff underneath it, so that's why I have the waterfall. Something more local to Central New York, Watkins Glen State Park has the infamous scene where the trail goes behind the waterfall. If you ever hike behind the waterfall, you look up, you can see that there's a harder rock layer right there that kind of sticks out And then here's like a layer of shale that kind of erodes back. That gives the overhang and allows you to walk behind the falls like that. All right. Now I'll show you some examples of that. All right, so this is the waterfalls at Tahanic Falls State Park near Ithaca. And what you should see here are a few things. One, with the shape of the land. All right, so here it's pretty much straight up and down. Here it's more of a gentle slope. And then here it's more of a gentle slope. And you see what the rock layers are, where it's straight up and down. It's a sandstone. I said before, sandstone's a fairly hard rock, straight up and down. Shale, they both have the gradual slopes there. So you can see how the gradual slope is softer rock, straight up and down is the harder rock. All right. Now, over here, here's the actual waterfall itself. And the stream has cut down into the layer of shale. So it's eroded down, but the erosion reached the sandstone layer, which is a hard layer. Now down here, I have a softer layer. So what happened is this one eroded backwards, letting the sandstone have an overhang, and that's creating the waterfall. That's why you have the overhang and the big waterfall right there, right? Because I have a harder rock layer. So here's the stream right here. I have a harder rock layer over a softer rock layer, and that creates overhang. Because this one does not erode as much, this one erodes a lot. So that overhang causes the big waterfall right there. Another example of that. Right here. This is, again, Tahanic Falls State Park, but this is like right at the very beginning. So here I have a waterfall right there. This layer right here is a limestone, which again, limestone's a fairly hard rock layer. Underneath it, I have a layer of shale. So the shale stuff has eroded back, causing the overhang, which makes the waterfall. So again, with the waterfall, I have a harder rock layer sitting on top of a softer rock layer, and that's why I have the waterfall there. And here's just a diagram of the rocks in the area, those pictures we just looked at. Again, there's a layer of limestone, a layer of limestone, a layer of limestone, a layer of limestone. You can see the layers of limestone stick out farther where the softer shale erodes more. So there'd be a waterfall. So wherever I have the place where the limestone sticks out and the softer shale goes underneath it, that's the place that could potentially be a waterfall. So the more resistant stuff sticks out, the less resistant stuff erodes in. All right, one last thing I want to point out with the landscapes here. One other thing that can affect the landscapes, the shape of the land quite a bit, is humans. All right, Now, this graph right here, let's say that's 1500, 1600, 1700, 1800, 1900, 2000. All right. So those are years in the bottom. Here are people on the side. If I were to make a graph at the world population, what my graph would look like is something that looks like that. All right. Over the last 150 years or so, the world population has skyrocketed quite a bit, and largely due to advances in medicine. You have things like penicillin now that can, and antibiotics that can kill off infections, and we have vaccines and stuff like that. So world population's increasing quite a bit. Now, people got to live someplace, right? So what happens is when people have to live someplace, they, a lot of times they'll end up cutting down a bunch of trees, or the side of hills. They'll kind of make a bunch of terraces in the side of hills. When they build roads, they might have to like carve out like a notch out of the side of the mountain to make a road, or they might have to drill a tunnel through a mountain to make a road. So to accommodate all these people, we're having to change the shape of the land and other things. With all these people, if I were to have a graph of the amount of carbon dioxide, it'd be a graph that has a similar shape to that. Well, the more carbon dioxide you have, the warmer conditions you can have. So in some places it's going to be drier, so it could change the landscape with a change in the climate as a result of the increase of carbon dioxide. Some activities that people do, they increase the amount of erosion. So humans, again, which we're having a more and more larger effect on the Earth because there's more and more of us, can affect these in a variety of ways, right? And as a result, affect the landscapes too. All right, so that is environmental factors and landscape development.